All right, guys, welcome back to Better Biomed. Today is an unscheduled and unexpected video, but this has become such a problem that I can no longer ignore all the LED failures that I've been seeing lately. And because of that, we're going to take some time today and take a look at some of these examples that I have right here that are just something's messing up. So give me just a few minutes. Let's allow some people to log in, since I never broadcast that I was going to be doing this, but you know, it is what it is. So I have one item that I just took down today, and I'm pretty upset about that one. That's all right. I've got a ceiling light fixture right here that is already pretty much taken apart. And I've got a transformer right here from a professional job that recently failed. So why are they failing? Well, part of the reason that they're failing is in their construction. So it's widely known that LEDs, when they first came out, they were reasonably expensive. And since then, more and more companies have gotten into producing LEDs, and in doing so, they've decreased the cost. The components have gotten cheaper. The ability to manufacture them has gotten excessively cheaper, to the point now where you get an entire light ceiling fixture for like 20, 30 bucks. Something that would easily cost $100 to $200 just a few years ago. So now we have cheap ceiling fixtures. Or I should say inexpensive, but possibly also cheaply built. So I've got a few of these examples right here. We're going to go ahead and switch the camera over, and let's go ahead and let's take a look and see what we got me, because these things are dropping like flies. Why are my LED lights dropping like flies? All right, so let's start out with the professional transformer right here. Let's go ahead and let's take a look at what we are dealing with this guy. And please excuse me while I adjust my specialty camera. All right. Well, there's a little bit of an artifact in the screen. Hold on, we can do better than that. Okay, how about that? Okay, guys. So this right here is a transformer to what model was this? Oh yeah, it's a Heraeus. This is a Heraeus inspection light that you'd see in small procedure rooms, sometimes mother-baby wards, you know, ERs, stuff like that. Well, this transformer right here, when I was doing my inspection, the symptom is that the light is on, but the light is dim. And that is obviously unusual. And I've had several other videos that I've done where I've told people very openly that just because you have voltage does not mean that you have amps. As soon as you put a load on a power supply, if the power supply is defective, then what you're going to have is power sag. So your current is going to drop right off, and obviously your voltage is also going to drop off at that time. That's what this guy was doing. So this guy right here is a transformer for a Heraeus overhead ceiling light. It is basically a regulated DC power supply slash LED driver. It's all kind of incorporated into the same thing. And the symptom was that I had, let's see, I think it was 10 or 11 volts. I think it was like 10 volts, so a little bit lower than what it was supposed to be having. This guy here is, what, a 24 volt? I think this is a 24 volt power supply. I was sitting at 10 or 11 volts. But as soon as I flicked the light on, the voltage dropped right off, and that's wild. And I noticed that the voltage recovered whenever I shut the light off. So that's an odd thing. I mean, just because you have voltage, just because that's the one section of your multimeter that you're most familiar with, that doesn't tell the whole story. And since it doesn't tell the whole story, you got to dig a little bit deeper. And obviously, power supplies should be tested when they're under load. Which means, yes, I can test it, but as soon as I flick the light on down at the head, it starts making this guy work. And can see one of the symptoms right there. See that discoloration? It's interesting, isn't it? So something got hot. Something right here, particularly, got excessively hot. Well, when we flip this guy over and we take a look, so your AC mains comes in on this side. We've got line and neutral on screw down blocks, which, Haraeus, if you guys are watching this, what a garbage design. And I understand that you guys probably just relabeled somebody else's power supply. But I want you guys to take a look at this one major flaw that I had. So normally, a power supply or transformer above ceiling, you can disconnect it conductor by conductor, and even on a live circuit, so you don't have to kill the breaker. If you do it correctly, you can do it safely. But there is no safe way to do it on this guy unless you have some really good insulated drivers, because you can see the through holes right here for the line, neutral, and ground are going through a metal shield. So as soon as you come down and you make contact with one of these screw down blocks, that utensil is now live, and if you're going through a metal shield, it is now going to be live and arcing because it's at earth potential. So isn't that just wild that that type of thing could happen? So it was a horrible design. We had to track down a circuit breaker and kill the circuit breaker, which in older medical facilities is not easy to do. It's actually miserable. And Haraeus, I hope you guys fix that. All they had to do is trim back this shield just a half an inch. Just a half an inch, if that's what their suppliers did. And what you can see is they, on the inside, they had the circuit board, the PCB, actually soldered to the shield. So there is a ground plane going around the periphery right here. And your earth is also on that plane. And it's soldered to the shield. Now this does a couple things quite well. By soldering the circuit board and surrounding it with an earth plane, including here, what you're essentially doing is creating a Faraday cage to keep the noise, because this is a power supply. Power supplies have chopper drivers, and your chopper drivers are going to create a lot of noise because they're buzzing. So the way that you stop that from happening is you surround it with metal and you ground it, and any of those ancillary noise signals would get, swept away to the ground plane. So that's why it's got this all the way around. That is why it was soldered, is to unify that Faraday cage, essentially. So here we are. Something got hot right here. And what do you think got hot? Tell you what. This might be an excellent video to implement the magic eyes, okay? Here, let me turn this guy on. Probably should have had this all on before I started recording the video, right? I just feel like this guy gives a much better image than this guy when it comes to detail. Details. There we go. And let me have some light. All right. Now I know it's blown out on this camera, but it's all going to make perfect sense as soon as I switch us over. There we go. Okay. So here is the area in question. You can see that it got a wee bit hot. That is exactly on the back side of this guy. You see that? Now this is non-conductive. Very smart for them to put that there. What's on the other side? Well, you guys, I talk to you guys all the time about identifying your components. That right there is a bridge rectifier. So you can see the AC waves on one side, and you can see that there's a DC output on the other side. Pretty plainly, you can make that out quite easily. So let's track down what's going on through this guy. So on this side, we have our line that comes in. It goes through a common mode choke, and we have a couple filter capacitors. And let's see, what do we got right here? AC 250 volt. Yeah, so we got we got all these capacitors right here stacked up. we have our line fuse. So this guy's only for line. This does not have fusing for the neutral. And we got a couple mauves right here to help for any surges. And then the AC comes through over here. And actually, I think it's stripping off a little bit of the AC right here to power this guy. But anyway, right here is your bridge rectifier, which converts your AC to DC. And on this side is the DC. You've got a larger capacitor right there. Now you're on your DC side. It's going to be chopped and then rectified. And then this over here, your wires, are your output. How crazy. So that is the power supply, although this guy's a little bit different because it has a transformer. Huh. Oh, that's interesting. Now, is this... Right there's your transformer. Going right to your outputs. So, by the looks of it, this guy is outputting AC. That's what it looks like. I thought for sure that this was a DC power supply. And it doesn't say, you know, Heraeus. I might have to find a data sheet for it, but you can tell it's German. Hey Catherine, how you doing down there? So you can see it's 65 VA. It's just definitely different how they market. But you should never see a transformer near the output unless it's going to be a AC power supply. Interesting. I wish I had more of an explanation on that for what's going on. So anyway, this over here is the input. It goes all the way through. That's your output. And we clearly see that the bridge rectifier right here, which is essentially just a diode network, it is messing up. And it's messing up pretty bad to the point where it almost looks like something was coming unsoldered right there. See that? There's definitely a problem with that solder joint, which actually might only be the problem. Maybe if I reflowed it, because it did have some voltage coming through, but it was not very clear. Yeah, I bet you I can push that component. Yeah, I can push the component out. See that? So that would be the corner of that bridge rectifier right there. I can push it out. Is it? Yep, sure is. Right? No, it's right next to the bridge rectifier. And that would be, sorry guys, my camera angle's all messed up. That's that capacitor. That's that capacitor right there. So the bridge, even though it's not sitting flat to the board, the leg on that capacitor is loose in its socket. And that's that point right there. We can fix that. I'm doing excellent, Catherine. Excellent. I've got some major news that I might be releasing for the future of this channel, man. Some big things are happening. Big things, way bigger than maybe I'm ready for. But anyway, guys, so this guy here is an industrial level part, and man, that looks so cool on that green screen. It failed because of what looks like a bad solder job on one of the legs. Not really worth me going into much more detail on it because I don't have a load for it. If I had my light here, I would definitely hook it up and let's see what catches fire. But I don't. So that's just the anatomy of the inside of it. And the fact that one single component got a little too hot. There was two of these copper. Man, even the copper has an interesting effect with the chroma key. So these right here were on those two chopper drivers, or diodes, rectifying diodes. And these here were the heatsink for it. And it's all located inside that case. Pretty cool, huh? So those heat sinks were messy. In fact, my table's getting messy all over again. So guys, this right here is a ceiling fixture that I replaced just this last week. And it's not very old. You can tell it's not very old. I mean, first off, it's got build dates on it. but it's not very old at all. In fact, I think I bought this last fall, and this one is in a pantry, so it doesn't even stay on or anything very long. Right? And so this guy is just one of those things. Here, that probably helps out. Yeah, so it flicks on, flicks off in a pantry. Sometimes they leave it on. God, that just drives me crazy. But it is what it is. Now, I would love to hook up just the LED panel and do something cool, like maybe give a demonstration. But this is an LED network. And an LED network means that they need a high line voltage in order to illuminate this whole entire disc. So the ways that you can drive an LED is you can drive an LED with a driver, a simple driver, or you can put diodes in a network, and each diode is going to drop a certain amount of voltage, and that's why, you know, it's less work for the driver, because all you'd have to do is rectify like mains voltage if you have enough LEDs. Each of them have you know, a certain voltage drop, and that's how the whole thing gets illuminated. But the driver is still needed because LEDs want to pull maximum amps. Maximum amps. So if I were to put a DC power supply on each one of these LEDs, I bet you every single one of them would be just fine. But this disc right here, it says 94 volts is what it takes. 94 volts. I have a 30 volt power supply, and I don't know how to get 90 volts. I mean, I guess I could also get like a driver or adjustable power supply, but it's just not worth it. The disc is probably absolutely fine. The disc sits underneath this diffuser, which, you know, diffuses the light to a more even pattern, and in the middle here is where the driver sits. So pretty simple design, pretty cheap. I think this is probably a $40 or $50 light supply, or light source. I have never checked this guy out. It just up and failed one day, and well, I guess maybe that's what we should do today, is check out and see what the heck happened. There's no visible signs of heat damage, and as far as I can tell, there's no indicators of short circuit or major failure. But we have had several brownouts and, you know, defective power for the house is a pretty good indicator of, you know, things starting to drop dead. So one of the things that you should notice is right here, always by your mains, you're going to see some sort of fusing. Now, it might not be labeled a fuse. Like this one here is a resistor that's labeled F1. How convenient. Often, you don't have any indicator whatsoever that you have some sort of fuse. It might be just a component that's designed to explode. But this one has a fuse, and I've never tested it to see if the fuse is good. Let's test the bottom side. Uh-oh. Tell you what, let me show you what's going on. So I'm testing the top and the bottom of the fuse. Here's my meter. $10 ohms? No way. And the fact that it's not jumping right away. So what I'm seeing is I measure across this guy and I'm getting 10 ohms, but really what's happening, there's no way that that's a 10 ohm resistor. You think? It's not even acting normal. Like it's got some delay. There it goes. On the bottom side, it had some major delay. Come on. It is a 10 ohm resistor. Wow. Okay. But it's clearly labeled as my fuse. And it's not popped. So this guy is just straight up dead in the water. Like I said, I don't see any signs of fatigue. You would think that it would have popped the fuse if there was a major issue. So let's see, my output is soldered on the bottom here. I think it's over here on the side. I should have probably took more notes before I disconnected the disc. So this guy right here, oh, these wires, I think, go through here, and they went to the bottom, which is that guy. Again, a lot of this is a little bit of speculation because I wasn't planning on making this video when I did it. I just took it down, I replaced it real quick, and I was like, all right, enough's enough. What I'm doing is I'm looking at the power, what is that, a power regulator? And obviously we're going to have an LED driver. Well, maybe for another video I'll have to hook this guy up with mains and see where the voltage fails. So my caps are good. As far as I know, my semiconductors are not defective. No, because it usually would have popped the mains fuse on the other side if it was bad. Okay. Well, this guy here has no signs of failure. It's probably going to be like one of these little components right here that my probe is on. Here, let's see if I can get you up nice and close. A couple of these guys are a little bit suspect. There we go. So this blob right here is a little suspect. Almost looks like it blew open or something. I don't know. And most of these look like they're all right. Usually there's some sort of signs of heat damage. And this right here is my bridge rectifier. This little guy right here. You can barely make out the plus right there and the minus. So AC's on this side, DC's on that side. This guy could be the failure point. Could be. Let's see. Put this guy in diode mode. Let's see what we got. Nothing. We got 0.5 on that one. Got nothing. Okay, that one's good. Got nothing. Oh, come on. It almost looks like there's a conformal coating or something in it. It's so shiny. Okay, I got 0.595 that direction. And on this direction here, I've got nothing. So this bridge right here should be just fine. The diodes appear to be intact. It's probably the LED driver itself. Could be this guy. Almost looks like it got a little hot there, doesn't it? Look at that upper corner. Yeah. Oh well. So that's my LED driver for my ceiling light that just quit out of nowhere. And let's see. No, those caps are fine. Okay. That sucks. So let's go ahead and switch it. And let me show you guys the repair that I just had to do in my house right now. Little upsetting because it's not that old. Again, you know, a lot of these products, the wiring, how they're soldered down, a lot of this is just not very good. Not very good at all. So this is one of the coolest products I've seen in a while. And it worked fine. It worked beautifully. In fact, a lot of the functionality works fine now. What this guy is it's a ceiling fan slash light. And this guy is one of the coolest products I've found out there. So this guy right here, it rotates around so it circulates air around the room. I just installed the newer version of this, and there's a couple details that are a little bit different. Like on the new version, the controller is different. Now when you see something like a controller, because that's going to be an expensive remake, the controller is different on the other one, and usually that happens when there's a revision, and there's usually revisions because of things like failures. So is this guy worth fixing? It might be. It might be. The symptom is that the fan still turns on. It runs beautifully. But the LED lights, they flickered a little bit, and now they will not turn on. So, since my LED strip is not turned on, again, there's probably an LED matrix around the outside. So we're talking probably a larger voltage going out for the LEDs. And again, I have no idea how many LEDs are in here. You'd kind of have to know that in order to understand, you know, what the supply voltage is, or measure it. But this right here is my controller. Let's go ahead and pop you guys into it. So on the new fan, I did not see, well, it's a lot simpler for one. I did not see a capacitor for my new fan. That's interesting. I'm really kind of curious. So we got 4 wires going down here, so that would be, what, a 2-pole fan? And then right here is a capacitor, which would be your start-run capacitor for your motor. And you guys that have had the air conditioner outside that sits there and buzzes and it doesn't actually get cold, same thing. You need that capacitor to basically like jumpstart the fan and, you know, get it spinning. I could get into more detail on that. I think I already did in another video. But so anyway, let's go ahead and take a look at what we got going on here. On this controller, over here is my LED out. So that would be these 2 or 3 wires. Yeah, 2 or 3 wires. And then over here, I've got this is a set of wires for the spinema thing that distributes the air. So there is a motor down there that actually powers that wheel that rotates, this guy down here. There is a motor on that, and so this is the main motor. This is the other motor. This guy right here is for communications. Right here's my AC mains in. And let's see, where is my pointer? Well, we'll go ahead and use a pen for my pointer this time. Okay. So with almost all these devices, you have to divide up the functionality according to the inputs and outputs. So what you can see right here is there's like a cross section where this is going to be your DC power supply section right here. So we have a rectifier right here, and we have our large capacitor. This large capacitor right here is probably our higher or high voltage DC. And let's see, what is this little guy? Man, my eyes are definitely not as good as they used to be. Almost looks like a fuse right there. But that's traditionally a capacitor. I don't know. Hold on, guys. I'm too curious. I just pulled this down from the ceiling, and I'm bringing it in here. I've never looked inside it. Let's switch it over to the scope. Okay, so there's the component in question. And let's put some light on the situation. Okay, SMT 5 amp 250 volt. It is a fuse F1 right there. That's curious. Maybe a good lead. I'm very curious because let's switch it. Since we can dissect a control board into its functions, we know that the DC power supply is right here, the fan is over here. These diodes right here are almost definitely the fan drivers, and this right here is your driver chip, which also has a little TX right here and this antenna wire, so it also does your communications, and it's going to thunder shower. Lovely. So it looks like there's a previous revision that had capacitors. They pulled them off for cost reasons. We have 2 drivers right here, and I believe why we have 2 different drivers right here, these guys I think are for the LED circuit, the LED drivers. The reason I think that is because this guy has adjustable temperature, which means you have to drive multiple sets of LEDs in order to obtain, like, when we say temperature, we're not saying like physical temperature. Your color temperature is the whiteness of the light. Like this light right here is more like a 5K. The one that's up here on the microscope is probably more like a 4.5K. The higher the kilo rating, or the K, the whiter and the brighter the light. So you've all seen the yellowish, the soft white lights in your house. Those are going to be 35 to 4,000 K, and the higher the K or the kilo, you know, the more white the light is. And that means that they're going to have multiple LEDs around the ring, and you're going to have to drive them independently, which is why we have 3 wires. So one of them is obviously going to be your ground or your negative. The other 2 are going to be positives for the different types of LEDs to achieve the variable color temperature. And that means that I could also test the exact same way. I could hook up, if I had like a 100-volt DC power supply, we could probably do it. We could almost certainly do it. Most benchtop power supplies go up to like 30 volts. So, but anyway, so that means that this section right here is almost definitely for the LEDs. I'm a little bit curious about that F1, that fuse. This guy right here. Because it just up and quit, and it almost looks like that fuse. Yeah, that F1 is definitely going to be for the AC in. So you can see right here, this is your hot lead, the black, and it goes immediately to your fuse, and then it goes through your capacitor right here for filtering, and then it will go over here to your bridge rectifier, which is squeezed in between the 2. So that little thin guy right there is your bridge rectifier. Outside of that, you have your high voltage DC, and that will get transported around to your drivers, etc. So I have a problem over in this section, almost definitely. Not really worth exploring, because this guy is not very old. And in fact, I believe I'm still within the return policy for Amazon. Yes, Amazon's got a huge plus. So what I'm going to do is I'm going to put this guy back in its box, make it look beautiful, and I'm going to return it because I have the new one installed, and I'm going to return this one back to Amazon because something is not right. It's sketchy, very sketchy. But yeah, since I opened up the new one and I see it's got a new control module, that's usually a big indicator that they're trying to refine their product, because as with anything, I mean, once you manufacture a product, you're going to realize that, hey, this product has some problems. Maybe Amazon has a high return rate or something, and in doing so, they had to refit. And I think the motor's different too, because like I said, I did not see a start capacitor on the new motor. I wonder if they switched to an all DC motor. Curious. But anyway, this guy here, it is a nice ceiling fan slash light, and especially if you have like in kids rooms and stuff, and you don't want, you know, kids maybe throwing stuff up in the fan like that ever happens. And if you want it to be totally encapsulated and safe, this is the light that I generally choose. It's about $100 on Amazon, and I'll leave a link in the video description. Usually you wouldn't try and share a product with people if it had failed, but I really do think that this product right here solves a lot of problems. I mean, it was super easy to install. You know, you got 3 wires, you got your ground and your hot and neutral, some wire nuts, and it fits up into a bracket that you screw into your existing lighting fixture, and just pop it up and rotate it and you're good. Super easy, guys. So I got some questions here. What are some beginner's projects for first year bomb? Ooh, that's a good one. I'll tell you what, hold on. Let's see what we have. Hold on, let me switch to straight over desk. Bam, there we go. Hold on, guys. Oh, Roxy, watch out. Come on, Fatty. What are some good projects for beginners? Well, I'll tell you what, I just found a bunch of these little guys over here. Where are you? Where are you? Come on. There we go. It just so happens that I have taught a lot of people about things like soldering and electronics, and in doing so, I've accumulated a lot of stuff. Okay, we'll put that guy up. And this guy down. There we go. So some of the things that you can do to get yourself started to improve your skill sets. One of the things you can do is get these guys. These are so inexpensive. This is what, Bojack, and it's a 40-piece kit. You can design your own electronics, super cool, or you can use this to practice your soldering skills. Like here's an example from one that I gave some students, and this was so that they can see what it looks like when the leads are pushed through. See that? And what they should look like when they're soldered. So that is one of the things that you can do, is practice on these guys. Now that is obviously only for electronics. One of the things that you can do if you want to get better is you go around and you pull stuff out of the trash. Not kidding. If you guys only knew how much opportunity is out there in the trash. I put somebody completely through college by pulling stuff out of the trash, stuff that people throw alongside the road, fixing it, and then selling it. Dead serious. Put somebody through college that way. And then, I mean, I split off into other things like, you know, fixing ATVs and stuff, but it was always fixing stuff that people generally didn't want. And that's how I ended up, me and my family ended up pretty much debt-free, is because scrounging. The trash is an amazing source of free stuff that you can, I mean, if you fix it, yay, you can sell it. And if you break it further, oh well, right? That just means your trash can's a little bit fuller than your usual. The trash is an amazing place to start as a person that's trying to get used to fixing things. Every single trash day I drive through these neighborhoods, I find vacuum cleaners. Every single time. And usually there's nothing wrong with them. They usually just need cleaning. Or maybe they need a drive belt for if they have a motor head down at the floor. It's usually a cleaning though, and that's usually why people throw them out. It's crazy. But one of the other things you can do are these little electronics kits like these, right? And if you like biomed electronics kits, my friend Brian Bell has a kit, which I will leave in the video description for him and his website. It's you know something, he can explain it way more than me. He does electronics kits just like this. You build them yourself for healthcare technology. So I did a whole video where you can build your own ECG and your ECG reader, or your simulator and your reader, and you can put those two together. In fact, I've got one or two of them here, and I need to yet do a video where I like hook those up to a computer, program it, and actually read some ECG. That's going to be pretty cool. I've just been traveling too much, but there's some good news there, guys, because I might be an independent contractor soon. Very independent. In other words, like my Better Biomed business has been taking off to the point where now, in order to do a good job at this stuff, I have to do less of other stuff. And now it's financially feasible that I can do that. So you're going to see a lot more variety of products and services and touring companies and all sorts of cool stuff that you guys probably will almost never get to see on the day in, day out. We're going to do it right here. So I'm going to make better videos. I now have an editor. So my editor, he's awesome. He's probably watching this right now, in fact. But that dude is a champ, and he helps me edit videos. When I do live streams like this, I'm actually taking a break on him, giving him some time to do other stuff. So that's why, one of the reasons I like live streams. This kit right here, the one that I'm building right here, is, what is this guy? It's like a time clock. But anyway, there's a variety of these style kits. They're called DIY kits. You can find them on Amazon, and they're inexpensive, pretty inexpensive. This one here, it is in Chinese. Lovely. If you have the Google Lens app in your phone, you can easily go through this entire kit. It's really not that difficult to find out. The markings, the silk screening on the PCB are pretty easy to read. And since it's easy to read, it's easy to figure out. Just got to mind your polarities. So your capacitors, they have a polarity. Your diodes have a polarity. Nobody's going to hold your hand through that. But what you should be aware of is the markings on the PCB and the markings on your components. You got to marry them up correctly. Make sure that your pin 1 on your IC chip is facing the pin 1. But that's general electronics. So these Chinese kits, although they're poorly documented, they're an excellent source for perfecting your knowledge of components and your ability to solder and repair electronics. Because almost everybody that I give these kits to, they don't put them together correctly the first time. And because they don't put them together correctly the first time, they're going to put them they're going to put them together correctly the second time for sure, or the third time. That's the way it is. But anyway, guys, those are some real viable reasons for perfecting your skills, man. And I have a variety of these little kits. Around Christmas time, I hand out the kits that allow people to build their own Christmas trees and stuff. That's what I've been doing with a lot of the money that I've earned from the Better Biomed channel for the last several years. Is I go around to schools and I hand out, you know, free things to the kids at schools. I do the giveaways. People that I meet and stuff that are interested in getting started, I'll hand out these little DIY soldering kits, and sometimes I'll have enough time to sit there and actually show people how to put them together, but it's a fun project nonetheless. So anyway, there's this kit. Notice how I'm putting all the components back immediately before I lose them, because I am just like any other person in the world. I will lose stuff in a heartbeat. So there we go. Let's put that guy back. Other things that you can do to improve your skills. Man, I'll tell you what. Since I'm talking about cool products, I was going to do a whole separate video on this guy. But this guy right here is so cool. Gives you some options for your house if you thought you didn't have options. And what this is it's a wireless light switch. That's right. A wireless light switch. So let's say you have a lighting fixture. Like the reason I got these ones is because I have this room where I wired in parallel an overhead light over a workbench, and the central room light, which was this fan, was in the middle of the room. And when you flick the light switch on, both of them came on at the same time. But then the complaint came up that somebody wants to use the fan, and they can't use the fan at night because both lights have to be on. I was like, you are so right. So once somebody identifies the problem with me, I will find a solution. And this is the solution. And what a cool, easy to use kit. So this module right here goes up in the ceiling above your existing lighting fixture, and you have, it's marked over here, your red and blue are your input, your white and black are your output. Super easy. You wire these two in, you wire these into your lighting fixture, like this guy right here. Wire them in 1 to 1. Stick this guy above ceiling, and then there's a simple pairing process to which you press the button until it's flashing while it's on. And when it's flashing, just hit the power on or power off for this guy, and you are good to go. It's super easy. And I'll tell you what, I like this so much that I think I might show you guys how to wire it up right now, live. Why not, right? What's the worst that could happen? So let's see. We have these all trimmed. Beautiful. And let's see, what would be a good one as a demo? I think as a demo, I want to wire this into a female socket so that we have a regular power cord that can be switched on and off. Oh, I'll let you guys see behind the scenes, because somebody left my door open, and that always drives me crazy because the humid air comes in the room. Let's see, what did I do with my IECs? They're all in here. Here we go. There's a male. There's this guy. All right. We're going to wire this guy up proper real quick for y'all. Okay. So let's see. We got several wires here. Not that one. That one looks good. Oh, here's a female. Okay. And here is a regular IEC. How do I want to do this? Okay. Let's see if I got another one. I'm reorganizing my shop, everybody, and that is why everything is out of place. There we go. Win. So sometime soon, I'm going to be doing electronics principles, a regular live stream where we talk about the things that you should know about electricity. All right, so because I absolutely hate these type of extension cords, this is going to be my subject. Let's do that. Let's chop that guy off like so. All right. So let's see. Nope. 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 All right. And also, when you're using wire nuts, often the ones that they provide for you are wrong. So always use the correct size wire nuts. Those ones are way too large. All right, here we go. Much better. So I have a wire connector kit, and it has lots of stuff in there, so I can do it right the first time. All right, so all we need is, those ones are kind of small, those ones are kind of small. Let's do 4 of these orange ones. All right, excellent. Good to go. So my 2-prong right here, this is going to be my victim. Let's go ahead and separate out this guy, strip him back. There we go. I hate these power cords, and trust me, as soon as this video is done, this guy's going to get trashed because I do not like these type of extension cords in my house. There we go. So as I said before, the red and the blue are going to be your inputs. They are apparently polarized, which is interesting because back in the 80s, like, nobody polarized anything. So the little prong on your polarized plug, polarized means that it only goes in the outlet one way. This one here is larger, this one here is smaller. It does matter, it does. So what we're going to do is we're going to find continuity to the hot lead. So I'm going to put my 1 meter probe in here. So we test out, we're good. Now we check these. Okay, and I'm going to bend that one over because that one there is my hot. There we go. And put my meter back. And on these ones, the red is going to be your hot. And they don't give you very much there. I usually strip it back a little bit further, give me some more material. There we go. A little bit better. So what I'm going to do, put these two in a little bit of a twist to keep them together. And mind you, I would never use wire nuts for something like this, but as a demo, it's a safe and effective way to prove a point quickly. All right, and we put the neutral and the blue together. The neutral is usually the white wire. They're using the European wiring codes, I think. So at this point, my power in is wired. And I'm going to put my cable up here. We're going to leave it there for a moment because now we're going to do the output. And let's see, what should we do for the outputs? I have a female right here. I guess we can wire that up. So whatever's connected to this guy, we can turn on and off at our leisure. All right, so let's put these two through here. All right, let's give the white a little bit of length. There we go. So there's no ground, unfortunately. There's a saying when you're putting together any sort of outlet, is that black to brass or it's your ass. It's true. It's a saying that they've been saying for a long time. And that just means that the brass is always going to be your hot lead. And you guys probably seen that my wire was a little too long. So what I ended up doing is folding over the end of the wire a little bit, just like that, and putting that in my screw down terminal. Come on, there we go. Like so. So the white goes to the nickel plated contact, and the black wire, your hot, goes to the brass colored contact. And we give it some proper tension. And we line this guy up. There we are. Excellent. All right. Well, one of these guys is not lined up. That's all right. It's safe for the time being, so we can prove the point. Let's see. What else do we need? How about a fan? That's safe enough for me to prove. All right. So here is my fan, which I will plug in. And I'll remove the infamous little battery protector. So that keeps your battery from bleeding off just naturally over time. So it does take an awkward little, what is that, a 123 alpha battery. It's an awkward size, but you can find them on Amazon and stuff quite easily. So now that we have that all set up, let's go ahead and plug her in. It is polarized. Oh, there we go. All right, so we are live. Here, let me get all the metal objects out of the way. So it is live, and it says in the instructions to press and hold this until it flashes. There we go, it's flashing. And then press up or down on this. You've seen it confirm. And now, let's see, let's flick this guy on. So now, if I flick it on, pretty cool, huh? I can shut it off. So if I wanted to even put something here at my bench so that I could remotely trigger it, this is how I would do it. And they have different varieties of this. This is the one that's normally above ceiling or in a box or something. They have the ones that are more meant for out in the open. It's more of a finished product, but nonetheless, they still often have the wireless dongle. There it is. So that turns on and shuts off the output. Pretty simple, right? So once people identify a problem, now we can find a solution. And it's really simple to hook up. So I'll leave a link for this product as well in the video description a little bit later on today. But guys, how cool is that? Some really neat stuff that I run into. This guy here solved the problem for the two lights that are wired in parallel. So now I can use the fan when the fan's working. So that guy, just 10 minutes ago, 15 minutes ago, I just traded it out, fixed it up in the ceiling, brought it out here, and I thought, let's just do a video real quick before I turn it in. It's a fascinating fan. I like it myself, but the new product is maybe a little bit better in some instances. It is what it is. Cool, worth checking out, easy to install if you guys want to upgrade your house. I know, guys, I've been a strong proponent of LED technology for a long time now, and the thing is it just seems like there's some bad actors out there that are selling products, and these products are miserable. I mean, that's the only way to say it. I mean, how else do they die so quickly? So that's the thing that we as consumers have to deal with now, is the fact that the market is flooded with cheaper products. I mean, the consumer gets what they want, right? We wanted cheaper products. They gave them to us. But in doing so, what we've got is worse products, I think. So, but cool nonetheless. So anyway, guys, that is my Saturday. I am sitting here fixing things around the house. I have so much stuff to fix, and as you guys seen with my workshop, I have been cleaning my workshop and doing a lot of stuff. And today's project is that bench over there to straighten it out. Oh my gosh. I got so much stuff from my previous job that was in boxes. And, you know, since I'm not at that job, I have all this stuff in boxes that I have to pull out. So anyway, there's some big changes that are going to be happening, guys. Look forward to it. It's going to be cool. I'm going to have a lot more content. This is one of those things that took years to create, though. I mean, if you guys can imagine, you know, doing videos for years, trying to get people to notice you, to take credit on you. You know, here's one of the crazy things, is when I do a video, I will get several thousand views on it, and a lot of people ask questions and stuff about that video, and then I charge, I don't know, it depends on type of video. I charge a fraction of what other companies, big, you know, larger companies are doing, and they have less of a following than I do. It's kind of weird, huh? It's like getting the industry to understand who I am and what I'm doing, and the fact that I'm reaching a larger audience is hard. It's very difficult, but we're getting there, guys. We're getting there. People are finally taking me and this project seriously. And in doing so, I have the ability to do cooler things. Cooler things. So anyway, guys, I thank you all for watching, very much so. And I hope to see you guys at one of the upcoming shows. In just a few weeks, I'm going to be in Colorado, and I'm very excited about that. So I hope to see you guys there. Also, MD Expo in Orlando coming up in October. That's a big one. That's a very big one, and I'll be there. Very excited about that one. I'll drive there myself if I have to, but I'll be there. It's going to be good. And several other shows. I'm coming to several other shows coming up in the next 2 months, so it's going to be busy. So guys, look forward to it. Thank you all for watching, and I'll see what videos my editor is done editing. Maybe I'll upload something later on today for you guys.